We are discussing the general characteristic of alkali and alkaline earth metal. This is you are already studied in plus 2 classes. It is very simple topic, but in the examination point of view it is very important. First characteristic is the electronic configuration. So the alkali metal has a general electronic configuration of Ns1, and for the alkaline earth metal it is Ns2. They have a strong tendency to lose the electron to get the noble gas electronic configuration. That's why they are most electropositive metal. And the common oxidation state of alkali metal is +1. Since they has a stronger tendency to lose the electron because the size of the atom is very large, so the influence of the nucleus in the outermost shell is very less, so they are easily lose the electron and to get the common cation as M plus, so the oxidation state is +1. Similarly, the alkaline earth metal shows the common oxidation state of +2. Since the electronic configuration Ns2, the outermost electron is strongly binded to the nucleus and it shows the noble gas electronic configuration. So it is more, so we have to give them extra energy to lose the second electron from the atom. Next is the size. Alkali metals are larger atomic size. The atomic size increases down the group. This is mainly due to as we move down the group, the number of the shell is increases and the screening effect of the inner electron is also increases. And alkaline earth metal smaller than alkali metal due to the increased nuclear charge. See here, this is the periodic table. So the largest size of the element goes to alkali metal. So in the alkali metal, when we move from top to bottom, the size is increases. This is mainly due to the influence of the nucleus in the outermost shell decrease periodically, and the number of the shell is increases and the screening effect of the inner electron. Then as we move from right to left, from the left to right, the size of the atom decreased regularly. This is mainly due to the electron is entering in the same shell and the nuclear charge is also increases. That's why the size of the second group element is less than alkali metal. Next is the density. You know that if you are keeping a stone in water, it definitely sinks. This is mainly due to the weight of a stone is concentrated in a very small area. But when we take the same weight of a feather, it is floated on the water. This is mainly due to the weight of the feather is concentrating on a large area. So similarly, when we compare the density of the first group element, it is increases when we move from top to bottom. This is mainly due to when we move from top to bottom, the size of the atom increases and the molecular mass is also increases. Next is the melting point and boiling point. As you know that the melting is a very simple process. When you consider the melting of ice, the binding energy between the water molecule is very less, so the ice melt at room temperature. See here, the melting point is represented by the green bar. From top to bottom, from lithium to cesium, the melting point decreases regularly. And boiling means When we consider the boiling of a water, the water molecule are binded by a strong hydrogen bonding. So we have to give the extra energy in the form of heat to boil the water. Similarly, when we compare the boiling point of the first group element from lithium to cesium, the blue bar represents the boiling point. It is decreases regularly. This is mainly due to the binding energy between the atom is very less in alkali and alkaline earth metal due to the large size. Next is the electrode potential. When an electrode is kept in contact with its solution, the metal tends to lose the electron, thus passing it into the solution. Thus, a potential difference is formed between the metal and the solution. Suppose a zinc rod is dipped in zinc sulfate solution. Definitely, zinc is converted into Zn2 plus and moving to the solution as Zn2 plus. So there is a potential difference is developed between the zinc rod and the surrounding Zn2 plus ion. So this is the electrode potential. So when we see the electrochemical series. The electrochemical series means it is the arrangement of the element in the increasing order of the standard reduction potential. This is the electrochemical series. In the top, we can see the lithium, the alkali metal, and followed by potassium, like that. So the alkali and alkaline earth metal is situated in the top of the electrochemical series. This shows that the first group and second group elements are strong metal. They have a tendency to lose the electron and to become metal cation. That means cation. The next is the ionization energy. Alkali metal low shows the low ionization energy. That means the alkali metal are larger in size. So the outermost shell and outermost electron in the outermost shell and the nucleus is very less. So we can easily remove the electron from the outermost shell. Next is the metallic character. They are strong metallic in character. And next is the atomic and ionic size. See here, the yellow balls represent the atomic size. When we move from top to bottom, the size of an atom increases, that you are already discussed. The next is the ionic size. The white one represents the ionic size. From the top to bottom, the ionic size increases regularly. But when we compare the atomic and ionic size, the white ball and yellow ball, the size of an ion decreases. This is mainly due to the last electron in the case of alkali metal, the last electron exists in the outermost shell. If you are removing the one electron, the size of the ion is reduced because we are removing the electron. Okay. Then all the metals we can easily cut the alkali metals by using a simple knife. Okay, thank you.